For this YouTube video, we're going to resolve these two forces into components along the V and the U axis that are featured here and here. Now, this can be really useful because a lot of the times you might want to find out exactly how much of a force is acting in a specific direction for individual problems. And so this is one method that can be used to accomplish that. So to resolve this along the V and U axis, we're going to rely on using the law of sines, which is basically just stated as A divided by sine of A is equal to B divided by sine of B, which is equal to C divided by sine of C. It is described by this triangle here, where the C, or the larger letter, is the opposite side and the smaller is the angle within the triangle with respect to that side. We'll also use the Parallelogram Law, which basically states that the resultant sum of two forces forms a parallelogram. So in this case, we have this force here, which can be force 1, and force 2, when added together, end up being equal to the force of the resultant. And this is another really useful principle. So the problem we're looking at is resolve force 1 into components along the U and V axes, and then we'll also resolve force 2 into components along the U and V axes, and then determine the magnitude of all these components. So to solve this problem, the first thing we got to do is diagram it and create our feeder body diagram. And I already went ahead and drew this before time because it would have taken too long. So for force 1, we can break up our diagram into being our force acting in this direction, 30 degrees from the U axis, and then force 1 component of U going in the U direction, and force 1 of the V component going in the V direction. And then we know from just using our mathematical intuition that we have a 105-degree angle here underneath there. The U axis is set 105 degrees from the V axis. And so once we have all of this information, we can begin on a solution. So for dealing with the force 1 here, we can take what we have up here, the information given to us, and transcribe it to the diagram. So we'll end up with force 1 being equal to (250 newtons). And then we have our 30 degrees. And then if we break this triangle up, we can get 30 degrees here. Since this is 105 and this is 30, then we know that we end up with 135 degrees. And so to get our full 180, we can tell that this remaining bit of angle has to be equal to 45 degrees. And so then if we have 45 degrees here and 30 degrees here, since a triangle has to have 180 degrees on the inside, we can tell that this last angle is the same as this angle, which is 105 degrees. And now that we have our triangle, we can go ahead and use the law of sines and the parallelogram rule to solve this problem. So then, with this information, we can determine that our force 1 in the v direction divided by sine of 30 will be equal to our force 1 total divided by sine of 105. And these are coming just from this here. We have our 30 degrees facing the force 1v side, and we have our 105 degrees facing our force 1 side. And so once we have this, we can rearrange algebraically and get F1 sine of 30 divided by sine of 105 is equal to our F1 of V, which is then equal to 250 when we sub in times 0.5, which is sine of 30 evaluated, divided by 0.966, which is sine of 105 evaluated. And this solves for 129.399 newtons of force, which is equal to our force component in the v direction for force 1. And so then we can use basically the same principle, law of sines again, for setting this up, where we end up with our force along the u direction, which is equivalent to our 45-degree angle, sine of 45. We can look at it here. We have 45, which goes along our u direction here. Is equal to our force 1 again, which is aligned with sine of 105. And we can just algebraically rearrange this again by multiplying sine of 45 over to the top side. And we'll get F1 of u, or force 1 in the u direction, is equal to force 1 times sine of 45 divided by sine of 105, which breaks down into 250 times 0.707. When you solve for sine of 45, divided by 0.966, which ends up coming out to 182.971 newtons, which is our two force components for our force number 1. Now for force number 2, it's basically the same deal. So for force 2, we have being equal to 150 newtons. We know that this is 105 degrees. Now this here total together is 75 degrees. And that since this is an opposite angle, it has to be 75 degrees as well, which means the total here has to be 105 degrees. Which means that this component right here has to end up being this subtracted 30 degrees, which gives us 75 degrees. And so we know that this leg is 75. We can then determine that since this is going to be the same as that angle, it'll be 30 degrees. This leaves this angle here in the corner to be 75 degrees as well, which means that since this triangle is just this triangle opposite, this will end up being 75 degrees, and this will end up being 75 degrees. So now that we have all the angles for this, and we know our force 2, we can once again just use the law of sines to set up everything and solve as needed. So we can start with our force in the v direction, which is across from our 30 degrees here. So force in v direction divided by sine of 30 is equal to our force 2, which we know, divided by sine of 75, since force 2 is opposite of sine 75. And so once again, we can just multiply our sine of 30 to this other side, and we get force 2 is equal to force 2 sine of 30 divided by sine of 75, which is equal to our 150 newtons times 0.5, which is sine of 30 evaluated, divided by 0.966, which is sine of 75 evaluated, which gives us 77.6 newtons total, which is our answer for our force 2v. And then for our force in the u direction, we just set that up as being force of u, which is across from sine of 75 again, because that angle faces that way, and is across from the force 2 of u. Is equal to our actual force 2 divided by sine of 75 again. Then we can just multiply sine of 75 over. And what we end up getting is sine of 75 over sine of 75. I'll actually write this out, I guess. So those cross and we get sine of 75, and then our sine of 75's cross off. And then we end up getting force 2 of u is equal to force 2, which means that force 2 of u is equal to force 2, which means that force 2 of u gives us 150 newtons, which is our answer. And that's how you solve this problem and resolve force 1 and force 2 and to its components along the v and u axis. So hopefully this was helpful to some of you, and feel free to leave questions in the comments below.